Okay, good morning everyone. So today, we're going to learn about one of the subtopic uh in DC current, that is the resistor when connected in series and the resistor are connected in parallel. Okay, so the first thing is you have to remember the symbol of the resistor. The symbol resistor, there are two types of the symbol resistor. One is with crest and trough, or we can call it as a zigzag symbol over here, one, or we can use a rectangle as a symbol for a resistor. Both can be used for a symbol for a resistor. First of all, there are two types of connection to a resistor in the circuit. First, we have, let's say we have here, we have a three resistor R1, R2, and RT are connected. Here we know that it is connected in a series. Okay, so three of them are connected in series, and we have a battery over here. We call it CMF battery. Okay, the supply of the current. So there will be current that is moving inside the battery. There's only one current, the same current that goes in and the same current goes out. Okay, so we have a V1, we have a V2, and we have V3. Okay, so we can see that if this happen, okay, in three of them are connected in series, okay, the current flow will be same because I equals to I1 equals to I2 and equals to I3 because there are no junction in the circuit. So assuming that the connecting wires have no resistance, okay, so zero resistance on the wire, not on the resistor but on the wire. The total potential difference V is given by V equals to V1 equals to V2 and equals to V3. Okay, V, the potential difference in the circuits are not same, but when we add up V, okay, when we add up V, it goes back to the question. When we have add up V1, add up with V2, add up with V3, we will equals back to the V of the EMF. Okay, so this is very basic thing. V1 plus V2 plus V3 back to V. So for the definition of resistance, V equals to IR, this is Ohm's law, V equals to IR, V1 equals to IR1, V2 equals to IR2, V3 equals to IR3, and V equals to I effective, okay. So IR effective equals to IR1 plus IR2 plus IR3. So R effective equals to R1, R2, R3 because the I has been divided. So divide by I, cancel I everything, so we have R effective if R1, R2, and R3. So R effective we call as the equivalent resistance when we have only one resistance in the analogous to have one resistance in the circuit. Okay, now if we have resistor are connected in parallel, so let's say we have a connected in parallel, so R1 over here, resistor 1, resistor 2, and resistor 3 are connected in parallel. We have current I, but you have seen that there are junction 1 junction, second junction, and third junction over here. So they are separated, current are divided into 3, but because they are connected in parallel, V1 over here, V2 over here, and V3 over here is equal. More or less, I1, R2, R3 later on will be will be will be um will be connected back to the junction, so it will be have the same same I as it was before it was separated into a junction. Okay, so let's say we have bigger here R1, R2, R3, and we have I1, I2, I3, and same V. So V equals to V1, V2, V3, V2, and V3. Okay, it is same as the V of the EMF. So the charge is conserved, therefore the total current I will be I, as I said, I, the one before, the I current before the current was separated by the junction, so equals to I1 equals to I1 plus I2 plus I3. So I1 is V over R. This is V equals to IR. Came from Ohm's law. V equals to IR equals to I equals to V over R. I2 equals to V over R2. I3 equals to V over R3. I equals to V over R effective. Okay. So V over R effective is equals to, when you add up divided by V everything, then you have I over R reference equals to IR1 plus IR2 plus IR3. Okay, so this is a formula when you have a resistor are connected in parallel. Okay, most students tend to make mistake. They tend to have a R reference equals to 1 over R1 plus 1 over R2 plus 1 over R3. This is most common mistake, whereas actually the answer is 1 over R reference. So you have to flip up the answer. When you combine all the reference, the R in the circuit, you have to flip up. So 1 over R EF equals to 1 equals to 1 over R T. Okay, so you have to flip up the answer to get the R reference. Effective, sorry. So let's say we have an example here, example 18.12. Okay, we have a 1, 2, 3. Okay, this circuit we call as a combination of a parallel and series circuit. So two over here, R1, we name as R1, this is R2, and this is R3. R1 and R2 are connected in series. Okay, and R3 are connected with parallel with R1 and R2. Okay, so let's say we have to give for circuit diagram figure 18.9, calculate effective resistance of circuit. You have to add up R1, R2 and R3. Okay, B, the current pass through the 12 ohm resistor. How much the current pass through over here? So this is I over here. The potential difference across the 4 ohm resistor. So how much is the V over here? Okay, and the power delivered by the battery. How much is the power P power by the battery? And internal resistance of the battery may ignored. Okay, so we don't have the R. We only have R, big R over here. Okay, so for A, we have to combine R1, R2, R3. So we combine. What is the number when R1 plus R2? So we have R1. This is not R12. This is R1 plus R2. So R1 plus R2, R12, because they are connected in series. Okay, because they are connected in series. So R1, R1, 2, we have to add up directly. For 4 plus 12, then you have 16. So both of them here we have a 16 ohm. Okay, so R reference, R effective, there is between R12 and R12, between R12 and R3 is R1 over effective equals 1 over 16 plus 1 over 2. So this is 1 over 16. You put over here. So 1 over 2 became, because of the R3 equals to 2 ohm. Okay, over here. So we flip up, then you have R effective is 1.78 ohm. So actually, and it is the same as if you put one single resistor, you'll be 1.78 ohm. Is as equal as that 3 3 resistor. Okay, next for B, since R1, 2 and R3 are in parallel, does V1, 2 and V3 equals to V? Okay, So he says that it says that when you have R1, this is R1, this is R2, and this is R3. Okay. So since that V12 equals to V3, so V equals to 8 ohm, 8 volt. So it's taking another color. So this is V1, this is V2, and this is V. Okay. So actually three of them, this is a big, actually this is a big V1, this V, and this V, okay, is equals to the V of the EMF. Okay. Therefore, the current passed through the R2 is given by I1 V12 divided by R12 equals to 1 I2 8.0 divided by 16. So I2 equals to 0.5 ampere. Since R1, number C, since R1 and R2 are in series, okay, thus they have shared the same current I. So I1 equals to I2 equals to 0.50 ampere. Hence, the potential difference across R1. So V equals to R goes back to the Ohm's law. V equals to I1 R1. So V1 equals to 0.50, 4.0. So we have V1 equals to 2.0 volts. Okay. So remember, you cannot have a like V equals to I R in the formula. You have to determine it is the VI. So you have to fact this is VI. This is I1. So VI R1 and R1, then you have the same answer over here. You cannot have like a very general statement that V equals to IR. You have to determine this. Is this I1? Is this V1? Or this is R1? Then you can get the answer. Okay. The power delivered by the battery PV over R, okay, actually came from P equals to IV, okay, and goes by V equals to IR. So V squared over R, okay, if you do the substitution, so P equals to V8 squared divided by 1.78. So power will be 36.0 watt, okay, of the battery divided by the battery. So example over here is how you do the answer, do the working step by step. First of all, if you see this kind of a network of a circuit, the first thing is you have to do the furthest from the source. So let's say you have the diagram over there. Okay, what you have to do is do the, let's say this is the EMF of the battery over this side or the source. Okay, do the furthest from the source. Okay, do the furthest from the source, and then one by one, step by step, and then when you have fill up everything, when you have get the answer of one over the furthest from the source, and then you add up until you have the nearest to the source. Let's say this one. You can see that this resistor actually is not is actually hard for you to see when they do a diagonal resistor like this. Okay, what you can do is you have to arrange back. So this is the 10 ohm, okay, and then you have a 20 over here, and then you have a 10 ohm over here, then this is 5. So actually after you can see that this one is after the 10 goes to 10. Okay, so you have here, you have 5, and here also you have a 5. Okay, this is 5, this is 5. Let's check. For this one is over here. Okay, number 1. Number 2 at B here you have over here, also over here, same thing. Okay, and after the 20 ohm, you have a junction between 20 ohm and the 10 ohm over here. This one. For this, you have here this thing, this junction, and the junction over here goes to the 5, goes to the 5, and this junction over here also goes to the 5 and goes to the 5. Okay, so after you have rearranged, okay, you can start with 5 and 5 are connected in series. Okay, after you have finished up 5 and 5, you have new resistor equivalent over here. Okay, what you have to do, you have to combine that new effective resistance that with a certain number. I don't know what this number will be. Okay, you combine with the 10 over here. Okay, now if you combine the 10, you have a new resistor over there. So combine with the new one, you combine with the 20 over there. Okay, 20, and then you have a new over here, and then 10 with the new one. You can, right? We can see, yeah. Okay, 10 combine with the new, then you have a one list, one resistor remain. Okay, so if you do, you can see that there's solution over here. There's a solution, R1 plus R2, and then you have R12, and then R4 plus R123, then you have 5 ohm, and then you have R5 plus back with R1, 2, 3, 4, so you have total of 25. Okay, so the answer will be, the last one is R effective, where the last part is R1, 2, 3, 4 plus with R5 because they are connected in parallel. So 1 over 25, 1 over 10, then you have 7.14 ohm. Okay. So this is a exercise for you to do. Okay, you have one figure 18.21, figure 18.22, and this is the hardest, I think, 18.23. With the given answer over there. One, this is answer number 1, this is answer number 2, this is answer number 3. Okay, you can see a lot of network of resistor. You can try it for yourself and then check with the answer given. Okay, and then you have a 1 over here. You can pause the video and you can try to do the answer, do the working and find out the answer. Answer are given in the screen. This is number 2 also. Okay, and yeah, tomorrow we are going to continue with a Kirchhoff law. Okay, we're going to stop here, and you have remember to do all this exercise for yourself. Okay, see you again. Bye.